And then g of 3. We go to 3. We follow it up. Well, we don't have to. It's at 0. F of 3. So I go to 3. And I follow it up to the f, and it's at 5. Now I want to ask you something. What if I give you g of 3 plus f of 3? What's g of 3? G of 3 is 0, still 0. And then I add to it f of 3. What's f of 3? 5. And I get an answer of 5. So that's not bad, right? That works. It's not a bad day at all. But what if I ask you for g of negative 4 plus f of negative 4?
It doesn't work.
It doesn't work. It does not exist because g of negative 4, g is this graph, there is no part at negative 4. So I actually can't figure this out. So when I would add these two graphs, this actually tells me that my new coordinate on the addition graph would be 3 and 5. We're going to go into this in a second. I would get 3 and 5 as my new point on the adding graph. And this one does not exist. So the graph actually wouldn't exist at negative 4. Because it has to be, both graphs have to be there. That's where we're going to. That's where we're headed. So let's look down here.
What about E and F?
We're skipping them.
It's negative 3.
So we're going to look at example 1. For each pair of functions, determine h of x equals f of x plus g of x. Graph and label each function. State the domain and range. So h of x equals f of x, which is square root x minus 4. And then g of x, so plus 12. Now, this is why we did the radical and rational graph and polynomials and all those graphs before this happened. Because we're actually putting all those graphs together. So this looks a lot like not rationals the last unit, but the unit before that. Radicals, right? So, do we remember how we got domain and range from radicals? If you don't, and tomorrow you have the open book test on this, so hopefully you do.
There's a test
You have to find where, find the asymptotes. Is that right?
No, that's rationals. Radicals, remember it starts at 0, 0, and it goes to the right? What's the only thing that can move it? Translations, horizontal and vertical translations, right? And remember, our domain and range are both greater than or equal to our horizontal and vertical translations unless we have what? A reflection. Are there any reflections on here? Is there a negative here? No. Is there a negative here? No. So I know my domain is going to be x such that x is greater than or equal to what? 4. Because I moved 4 to the right. So now instead of being here, it's going to start at 4, right? And the rest of the graph will go like this. So it's greater than or equal to 4 XER, or in interval notation, square bracket 4 because it's equal to infinity.
Do we actually need to know intervals though?
Yeah. You go into any calculus, they only do interval notation.
I haven't heard a gospel reading in 2 years.
Range. It's because he has period 1 spare. He's trying to flaunt it.
For 2 years.
Okay. The range. That's the only, I've never heard someone flaunt range. I mean, flaunt period 1 spares that way, but okay.
Y,
I'd rather have it last period.
Y greater than or equal to 12.
Y is greater than or equal to 12. YER. Because it's moved up 12 and over 4. So the graph actually looks more like this. 4 and 12, and then to the right. Because that's the only thing that's happened, right? I haven't stretched it, I haven't narrowed it, I haven't pulled it up, I haven't shrunk it down, I haven't flipped it, I just moved it. Up 12, 4 right. We agree?
That's just the origin, right?
That's origin 0, 0. That's just like your starting point.
This is the only class that I come to school.
You can't even draw LA.
So I'm going to, this is what I'm going to do. So, this is what happens to people on tests. They go, okay, 4 and 12. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then they go here. If you're drawing off the graph, what was the point of drawing the graph? That's just ridiculous. So, does your scale have to go up by ones? No. So I'm going to make my y scale, so I just write y scale. I'm going to make it be 4s.
Couldn't you put the
I like
little,
I'm going to make it be
That's
2.
Smaller.
couldn't you put the heart monitor at the bottom?
Oh, I know what you're talking about, squishing it? No. Y scale, because this isn't like a bar chart.
Okay, but technically it would still mean that it skips a few.
Technically, you could say that, but this isn't a bar chart, and you can't do that on Cartesian planes.
Ooh. He doesn't know what those are.
Yeah,
I don't know
it's
what
this.
those call them, but
And then your x scale, I can make be going up by ones, that's fine. So I'm going to go over 1, 2, 3, 4. Now, when you make your scales different, you have to remember that. So some people will change their scales, and then partway through, they keep the scale, and then they draw the next point not with scale, and it's messy. So you go 1, 2, 3, 4, and then 2, 4, 6, 8, 10, 12. So it starts here. Now, we know with a radical graph, we don't even need our calculator. With a radical graph, we start at 0, 0, and then we go to 1, 1. Because your radical graph is y equals square root x, right? So if I plug a 1 in here, I'm going to get a 1 for my y. So now instead of it being at 1, 1, it's going to be moved 4 to the right and 12 up. So instead of 1, 1, it's going to be 5, 13. So we go to 5 and then 13, so that's part way. Our next coordinate is that I use is at 4 and 2, because I take a perfect square. Perfect square of 4 is 2. So my next coordinate's at 4 and 2. Now instead of it being at 4 and 2, I'm going to move it 4 to the right and 12 up. So instead of it being at 4 and 2, it's going to be at 4 to the right. So you my mapping, 4 plus 4. And then 12 up, 2 plus 12. So what's it going to be at? 8 and 14. Could you type square root x minus 4 plus 12 in your calculator and just draw it?
you could.
Yes.
You need to draw it like accurately. Or
Yeah, you have, if you have a calculator, which you do, yes. Because you can use your table of values, you can plug in any x and get out any y, right? So accuracy is important. Okay, for B, it has f of x is 2x plus 7 and g of x is 5x minus 11. And h of x equals, now it can be written like this, and I don't know why they do this, but if it's written like this, f plus g of x, if it's written with the f plus g together like that, the first thing you're going to always do is rewrite it as f of x plus g of x, which is what they gave to us. But I just want to remind you that they can write it weird like this, and the first thing you're going to do is not write it weird.
You multiply it in.
Sure.
So
Almost,
what
yeah.
is h of x?
So, because I felt like it. So h of x is going to equal f of x, which is 2x plus 7, plus g of x, which is 5x minus 11. The last one I couldn't do anything because there was no like terms, but what can I do to this one?
combine like terms.
Combine like terms. Someone's showing off with their vehicle.
Probably not even that star.
So you're going to go 2x plus 5x. I like how you assume that. 2x plus 5x is 7x. And then negative, or 7 minus 11 is? Negative 4. What is this equation in the end?
It's just 0.
That would be nothing.
It's a line. Thank you.
That,
That was a lot of random things being said.
is that minus 11?
Yeah.
My eyesight's getting better.
No, it's not. That's not true. Right after you ask if that's a negative 11, you say your eyesight is getting better.
Well, I thought it could have been the absolute power symbol.
That's not such a thing. It's just the absolute value.
Okay, well, what do you call that symbol on the keyboard?
Absolute value?
The bigger I.
Italics?
No.
On the keyboard.
Power.
You know, when you type absolute, right, you put it into two things.
Yeah, it's called an absolute value sign.
I know, what are those called though? Just one of them.
Absolute value sign?
No, just one of them.
Half of an absolute value sign? parentheses with not finished line,
It's not even a word.
an L, a 1. Okay, so
She is. Here.
this is your, the -4 is the what? The y-intercept. So I'm going to label these as my y scale of 1 and my x scale of 1. Now, Easton, this is an L and a 1. Easton, that's why you can't see. It's the texting. You're trying to find out what half of an absolute value sign is. It's called an L.
It's not called an L
Yeah.
because an L is smaller.
1, 2, 3, 4. So we go to -4, and this is our slope, 7/1. Make sure your phones are away, Andrew. So 7/1. Not you, Andrew. Up 7. You're not the only Andrew in here, Andrew.
It's called a Virgo.
Yeah, we just found that out.
1, 2, 3, 4, 5, 6, 7, 1. Andrew was looking it up.
A
1, 2,
Virgo.
3, 4, 5, 6, 7, and 1. Do we want to go over here?
It's also called a disambiguation.
Yeah, sounds right. So, there's my line. What's the domain of a line? XER, because whenever we disco, we get XER. Whenever we disco, we get YER. When our arms disco, even if we have a little curve in the middle, if it's cubic or degree 5, it's XER, YER.
If you're not changing the scales when and writing it,
What?
why did you write Y scale 1? if you're not
Because you
changing
can't
it?
assume that people know what it is.
So,
People are dumb.
You do it all the time.
yeah, you assume.
Normally they're numbered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you don't have to put scales on them because they're numbered. Yeah. All right, Scott, put away that phone. Okay. You guys are going to do C. What do you think a quadratic plus a quadratic is going to get you? A quadratic, yes. Yeah. So, h of x equals f of x, which is x squared minus 3x minus 2, plus x squared minus x plus 5. We're going to collect like terms. X squared and x squared is
2x squared,
2x squared. Minus 3x minus x.
18.
Yeah, minus 4x. And then minus 2 plus 5 is 3. So, type it into your calculator. Go. Type it in. Oh, don't ask. Like, I'm not even making you complete the square or anything. I'm literally asking you to type it into your y equals. Type it in.
6.
There's what, 6? I just want you to type the equation into your y equals.
Nice.
Marshall, type the equation into your y equals.
Have you ever got a phone call from unknown?
Once or twice.
Answer it.
No.
Yeah, put it on speaker.
Stop it. Don't. Marshall.
It's the committee of something, IRS.
You didn't leave them?
Yeah, try some guidance.
Touch and go. Okay. Did you type it in?
Yeah.
Everyone press graph. What's the important part for this if I want domain and range? To find the minimum, it goes up. That's good
I
too.
think it's 1 and 1.
So we go second trace. What?
Equals 0.
No. Second trace minimum. Left bound. Right bound.
1.
So we get 1, 1. Because you're just finding the minimum. You're not trying to find x-intercepts.
But didn't it ask for the domain?
Yeah, we're not there yet. We're just plotting it. So we have 1 and 1. And then how do we get other points? Yeah. Second graph, we go to table. So I have like 0 and 3. I have 1 and 1, 2 and 3. And then -1 and 9.
Isn't it reflected?
Nope, there's no negative. You need a negative x squared in order for it to be reflected.
No, but it's reflected on y or x equals 1.
What?
It's the same on each side, just what?
It's symmetrical?
Yeah, it's
Yeah.
reflected.
Not really, but okay.
If you had half of one, it would be reflected.
Okay. So my domain of a quadratic is what?
D,
X such that X an element of the reals. You were being very, yes, D is what we need for domain. Negative infinity, positive infinity, and interval notation. My range, it's like just random things that come out of there. What's my range?
Y, where R, colon, Y such that Y is greater than or equal to 1. Y is an element of real.
So an interval notation, that's square bracket because it's equal to 1, and then to positive infinity.
That's what I meant when I said D.
Why? Your Y starts at 1 and then it goes higher, Marshall.
Why did it start at 1 and not at...
You do on the graph, you just graph that you have.
3 is the Y-intercept, is that what you're thinking?
Yeah, but that's the intercept, not the...
Right, so the only way you can get it is by completing the square algebraically from grade 11, which we don't have to do, or calculator. Okay, example 2 we're going to go through, and then I'm going to let you do some questions. So here, the difference is the subtraction. Now, what do you have to watch out with subtractions as opposed to additions?
Negatives?
Absolute values, negatives.
Did we say the same thing?
Yes, you did, but it really, I don't... When you have a subtraction sign in between, what do you have to remember to do?
Negatives.
Yeah, like distribute that baby in, which is what I think you're meaning by, oh, I guess you're not.
No, I said why not negatives? It's always good to think about negatives.
Okay, so h of x in this case is going to be 10 minus the absolute value of x plus 3. When we have an absolute value, we're done. You can't put those together. You can't distribute the negative into the absolute value. This is done. This would be the end of it.
Yeah.
And we could type it into our calculator and we could look at it and give ourselves a domain and range. Absolute value sign, absolute value graphs give you that v. You go to top of grade 11. So it'd be xer. And then you just have to find the minimum. You didn't do it because of distance learning.
No, it makes a triangle.
No. It makes a V without a top, aka not a triangle. But you're going to say it's greater than or equal to, and in this case it would actually end up being, oh, it's less than or equal to 10 because it's reflected. Okay. With G, for B here, with G we actually have a two-term situation. So h of x equals f of x, which is 2x minus 5. But what we have to remember to do is subtract all of g of x, right? Not just the start of it. So we have to make sure we have it in brackets. So we're going to get 2x minus 5. And then this is the same as having a negative 1 in front, which changes our signs. If you don't show the first step, but you remember to distribute the minus sign through, that's fine. That's okay. But a lot of people who skip that first step don't put the negative sign through, and will only subtract the x and not the 8.
Was it x minus 13?
Yeah. Now, this means h of x equals x minus 13. This is actually a really easy lesson. What the hardest thing for me to get you guys to do is to stop solving it. Like, you guys will get to x minus 13, then you're like, is that equal to 0? X equals 13. No. Stop. Just h of x equals. So if every single time you write h of x equals, h of x equals, h of x equals, it might stop you from trying to set it equal to 0 and solve. Like, you have an addiction to
That
do
makes no sense. Why would you
decom.
do that?
Oh, you're going to.
Because the only way it's equal to 0 if you had y set equal to 0 to find x. But you're not finding the x misstep, so why would they do that?
Oh, if you do it,
You distribute the negative or square first?
No misstep, I don't do that.
distribute the negative or square what?
Square in the last question.
Distribute the negative.
Alright.
Can I go to work now?
No. So we have h of x equals f of x, which is x squared plus x plus 8 minus 2x squared minus 3x.
Can I?
Yeah,
No.
Legally he could.
Legally, he could do a lot of things, but
I could
not
leave
allowed.
when I was 16.
So we have x squared plus x plus 8, and then we have to change the signs behind. So we get minus 2x squared plus 3x. What do we do next?
Combine.
Combine like terms. So x squared minus 2x squared We get h of x equals
Negative x squared.
negative x squared. And then we get x plus 3x.
4x
Plus 8.
And then we get
plus 8
just 8 by itself. Plus 8.
plus 8.
Thanks. You get plus 8.
So we have maths brackets.
This one?
Exponents? Yeah. So that's the thing that confuses me. The negative.
Oh, you're
column-
talking this one here.
Yeah.
So we'd get h of x equal, I was so confused as to what you were talking about because I thought you were on this one. So here you're going to have to expand, then distribute. I get what you're asking now. So we get 4x minus 6 minus x minus 2 squared. So this is where ped math or bed math come in. Easton is infatuated with it. You have to do the exponent first, then this is a multiplication.
For a second. I was like, why did you say that?
I thought you were talking about this one and I didn't get where you were.
There's no
Ped
brackets.
math states that you have to
That's
do
why I was
brackets first.
So you're going to have x squared. Now what do you have to remember with x minus 2 squared?
It's different to square.
No, it's not.
Yeah, it is.
No, it's not.
X squared minus 4.
Nope, it's not. That's what you have to remember to not do.
Because if
X
plus-
minus 2 squared. What did I tell you to always do?
Plus or minus.
No. Cross out the squared and write it twice. X minus 2 squared means x minus 2 times x minus 2, which is not a difference.
X and square negative.
That gets you the wrong answer every time. Because x minus 2 squared means x minus 2 times x minus 2. X squared minus 4 means x minus 2 times x plus 2, which is not the same
Yeah,
thing.
that's a difference of squares, math.
Yes, you're right. Okay, negative 2 and negative 2 is negative 4x. Oh, I changed colors. And then negative 2 and negative 2 is plus 4. So we actually get 3 terms when we have that squared. So I was cross out the squared and write it twice so you don't,
Oh, you FOIL it?
yeah, so you don't just write a difference of squares.
Interesting.
Interesting. So we distribute and we're going to get 4x minus 6 minus x squared plus 4x minus 4. And then what do I do last? Every time if I can? Yeah, combine like terms. So we get negative x squared plus 4x is plus 8x. Minus 6 minus 4 is negative 10. So state, domain, and range after you have simplified. If you simplify it off, you have to watch yourself. So for example, this is what I want you to see. You're going to do this in a different one. But if I have square root 2x minus 1, I know that x has to be greater than or equal to a half. We agree? Because what can we only have under a square root symbol? Zeros or 0, 1, 2, 3, 4. Positives, right? 0 and positive. No, you can't take the square root of a negative number. Silly Billy. So we're going to have
Now
2x
trying to do it.
minus 1 is greater than or equal to 0, and we have to solve for x. We agree? You're checking it out with your calculator?
Yeah.
Oh, Easton.
That's my calculator. One
You used to be a teacher for the last 6
No, this is
Okay,
no.
so why did it give you an answer, Miss Lepp?
You took the square root of a negative number and it gave you an answer?
No, I put it on top of it on the thing like you said.
What?
I put it on the corner.
I have no
I took the negative 5.
So, the catch here is, we always have to, whenever we have a radical, watch for the radical because we can't have a negative underneath it. Now your homework for today is,
Where you go?
you talk like you always do your homework. He has been doing it recently. This is
I did do most of my homework.
You have been.
Yeah, we used to
But,
record.
you know, I didn't do it yesterday because I didn't have time.
I can send it to you.
Okay, that. Me and Ray are reviving the McDonald's yesterday. Or chicken nuggets. That's our whole.
This is your homework.
Why?
Copy it down.
You gonna post it in
Wonder why.